talking in this lesson, lesson 3-4, about lowest common multiple and greatest common factor. Let's start with the lowest common multiple. A multiple of a number is simply when you're counting by the number. Okay? Remember when you were in second grade? You count by 2s, 2, 4, 6, 8. Count by 3s, 3, 6, 9, 12, so on, so on. Those are all multiples of the number. Or if you think of the third multiple of 4, would be like 4, 8, 12. Okay? Because 4 times 3 is 12. When you're multiplying, you are just, or when you're finding the multiples, you're just counting by the numbers. So one method to find the lowest common multiple of two numbers is simply to count by the numbers, or list the numbers, list the multiples, and then circle the common one. The lowest common one. Okay? Sometimes, if you multiply the numbers, you'll get the lowest common multiple. Now that works anytime you have prime numbers. Like the lowest common multiple of 7 and 5, since they're both prime numbers, is 35. Right. Okay? 7 and but when you multiply the numbers, you don't always get the lowest common multiple. So there's another method then. This is more of an advanced method, but you would know how to do this. What you do is you factor each number. Just like in the last lesson, you learn how to write a factor tree, right? Look at the factorization of 4. That's 2 squared, right? And the factorization of 10 is 2 times 5. Right? So, instead of multiplying all of the factors, you only multiply the greatest power of each. So this one, the greatest power, since 2 is in both, you only use 2 squared. That's a bigger power than 2 to the first power. That's why I circled 2 squared here. Okay? Does that make sense? 2 squared is bigger than 1, 2. 2 to the first power. So I circled 2 squared, and I multiply that times the other factor, that is 5. 2 squared times 5 is 20. So again, you factor the numbers and then read that says, multiply the greatest power of each prime factor. The prime factors that are used are 2 and 5. 2's and 5's are used. And the 2 squared is the bigger power, so that's the one you use. Okay? That's that advanced method. Now, let's talk about GCF, the greatest common factor. You can start writing these notes. The greatest common factor, remember a factor is an ingredient in a number. Okay, these are numbers that go into the numbers. When we did the prime factorization, we're finding numbers that go into the composite number. Okay? To find the greatest one that both of them have, we factor the numbers and write the prime factorization and then circle the common factors. Circle the common prime factors. So, that's why when we look at this here, this one has 2 squared times 3. Everybody look up here for now. Just stop writing and pay attention to what I'm pointing at. So prime factorization of 12 is 2 squared times 3. Right? Nod your head? Yeah. And this one is 2 squared times 3 times 5. Right? Everybody see that? Now, which ones are in both? Well, the 2's are in both, and the 3's are in both. The 5 is not in both formulas. So we're only going to use the common factors. There's these 2 line up. There's this 2 in each one. There's this 2 in each one. And there's a 3 in each one. So those are the ones that we use. 2 times 2 times 3. Okay? When you multiply that, you get 12. That's the greatest common factor. That's the biggest number that goes into both numbers. 12 goes into 12 once, and 12 goes into 60 5 times. Okay? AJ.
Wouldn't it be 2 times 2, 3? Because they both have 3. So
Yeah, 2 squared times 3.
yeah, but
And that's that's common in both. Yep. So you multiply one set of the common factors.
Why wouldn't you do 5 then?
Well, since 5 is not in both numbers. 5 is not in this formula for 12. Is it? 5 doesn't go into 12. Okay? Now, there's another method, and that is, let's take the numbers 12, 18, and 30. Let's say that we had to find the greatest common factor. CF. 12, 18, and 30. Now, another method, when you have small numbers like this, would be just to list the factors. Okay? So, 12, what are the factors? All the factors of 12. Remember when we did this? 1 and 12. Whoa. So why? 2 and 6. 3 and 4. Do we have them all?
Yeah.
How do you know?
Because there's nothing you can go.
There's no one bigger than 12. 12 times 1 is 12. When you work from the outside